Hello, this is Mr. Collier, and today we're looking at the binomial theorem. So let's start by expanding a couple of expressions here. A plus b to the power of 0, that's 1. Anything to the power of 0 is 1. And then we have a plus b to the power of 1, that's just a plus b. Now we do a plus b squared, we'll get a squared plus 2b, 2ab plus b squared. And if we do a plus b cubed, we're going to get a cubed. Now you can work this out by just multiplying a plus b times this expression right here. We'll get a cubed plus 3a squared b plus a b squared plus b cubed. And if you do the same for a plus b to the power of 4, you get a to the power of 4 plus 4a cubed b plus 6a squared b squared plus 4ab cubed plus b to the power of 4. And you see a pattern developing. You're just starting with a to the power of this exponent, and then it becomes 1 less until it's a to the power of 0. And then the b starts with b to the power of 0, then b to the power of 1, b squared, b cubed. Okay, and then we got these, this should be a 3 here. Then we got these numbers in front called the binomial coefficients. In the last one here we have 1, 4, 6, 4, and 1 again are the binomial coefficients. And one way to get these coefficients is through Pascal's triangles. So if we start with a 1 up here, and the next row we do 1, 1. Then what we do to get the next row is you add these two numbers together and you get the next number. Okay, so we start with a 1, and 1 plus 2 is 3, 2 plus 1 is 3, then we get a 1. 1, now 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4, and then we get a 1. And then let's do one more. 1, 5, 10, 10, 5, 1. So, and you can keep going. Okay, so notice that these numbers here match our coefficients in each expression, right? We call this one, it might look like the 5th row, but we call this the 4th row because there's a 4 right here. This is the 3rd row, and this is the 2nd row. So if you want to do a plus b to the power of 3, you use the 3rd row. A plus b to the power of 5, you use the 5th row. Okay, so let's look at some examples now. Firstly, we have 1 plus 2x to the power of 4. So in this case, we can say the a is 1 and the b is 2x, and we can follow our pattern from before. First, you're going to have a to the power of 4, so that's just 1 to the power of 4. Plus, and then we have our binomial coefficient for the 4th row is 4. Times a to the power of 3. So we got 1 to the power of 4, now we're going to have 1 to the power of 3. And then we're going to have 2x to the power of 1. Next, we're going to have a 6 as our coefficient, 1 to the power of 2. And then we're going to have 2x squared. Okay, then our next coefficient is going to be 4. So we're going to have 4 times 1 to the power of 1. And then 2x cubed, and the final term is going to be, we'll have a coefficient of 1, and it's going to be 1 to the power of 0, and then 2x to the power of 4. And let's simplify. So this is 1, and this is going to be 8x, and this one here is going to be 2 squared is 4, 4 times 6 is 24, that's going to be x squared. Well, here we got 2 cubed is 8. 8 times 4 is 32, x cubed. And lastly, we have 2 to the power of 4 is 16, so we have 16x to the power of 4. Okay, let's try another one. Like this one here, we'll say a is 3 and b is negative. Don't forget that negative, 2x. And it's to the power of 3, so we're going to use the 3rd row, and we're going to have 4 terms, 1, 2, 3, 4. So first we're going to have 3 to the power of 3 plus our coefficient is 3. This guy is here to the power of 2. 3 to the power of 2. And then negative 2x to the power of 1. Plus, then we're going to have another 3. And this is going to become 3 to the power of 1. And this is going to be negative 2x squared. And lastly, we're going to have a 1. And then a 3 to the power of 0, which is also 1. So that's gone. And it's just going to be negative 2x to the power of 3. And let's simplify. This is 27. This is 3 times 3 times 3 is 27. Times 2 is 54. And here we have 2 squared is 4. 4 times 9 is 36. And lastly, we're going to have a minus 8x cubed. Okay, so let's do one more example. In this case, we've got a equals 2t and b equals, don't forget the negative, 1 over 4t. So we're going to start off with a to the power of 4. That's 2t to the power of 4. Plus the binomial coefficient is 4. If you check Pascal's triangle. Then you've got 2t to the power of 3, and then you've got negative 1 over 4t to the power of 1. Plus our binomial coefficient is 6 times 2t squared times negative 1 over 4t to the power of 2. Plus the binomial coefficient is 4 from Pascal's triangle. And then we've got 2t to the power of 1, negative 1 over 4t cubed. And lastly, the binomial coefficient is 1. 2t to the power of 0, which is 1. And this is negative 1 over 4t to the power of 4. Let's simplify that. This is 16t to the power of 4. We're going to have minus here. These two 4's cancel, so we're just going to have an 8. And this is going to be t cubed divided by a t is going to be t squared. Okay, the next one, it's going to be positive, because negative squared is positive. Let's see what we've got here. Here we have a 2 squared, and divided by, okay, wait, we got 2 squared is 4, 4 times 6 is 24, and then we're going to have 24 divided by 16. Let's write that for now. 24 out of 16. T squared is going to cancel with that t squared. And then we've got, actually this is going to be a negative. And we've got 4 times 2 is 8. We're going to have 8 over 64. This is going to be t divided by t cubed. This is going to have a t squared in the denominator. And here it's going to be plus, and this is 1 over 4 to the power of 4 is 256. T to the power of 4. And we can simplify these fractions a bit. 16t to the power of 4 minus 8t squared. This is going to be, let's divide by 8, we got 3 over 2. This is 1 over 8t squared, and this one stays the same, 256t to the power of 4. Okay, now the coefficients are getting a bit bigger. We have to the power of 7 here, so that would be 8 terms. It would be pretty huge, so we're going to look at a shortcut method now. What is the coefficient of x cubed? So the number basically in front of x cubed. So it's going to have 8 terms. We've got to figure out which one gives you x cubed first of all. And what we do is we can look at our formula booklet to find a shortcut. So in your formula booklet we have the basically the general way of finding these binomial expansions. And what we have here is the formula is a plus b to the power of n equals a to the power of n plus n choose 1. Okay, that's another way. That's a way of calculating the binomial coefficients as you saw in Pascal's triangle. And then we have a to the power of n minus 1, a to the power of n minus 2, and so on down to a to the power of 0. And the b's, as you can see here, is b to the power of 0 because there's nothing there. B to the power of 1, b to the power of 2, b to the power of 3, all the way up to b to the power of n. Okay, and here's how you calculate the binomial coefficients. You just do n factorial over r factorial times n minus r factorial. Okay, so if you do that for n equals 4, and and for r equals 0, 1, 2, 3, 4, you get the fourth row in Pascal's triangle. You get the numbers 1, 4, 6, 4, and then 1. Okay, so this is a way of calculating those coefficients instead of using Pascal's triangle. So we're going to use that in a second. So first of all, we've got this here, this binomial here, and let's say a is x and b is 1 over x, and n is 7. Okay, so let's take a close look at that formula again. Right in the middle, we have what we call the general term, so you can use that to figure out what the r value is. In other words, which term gives me x to the power of 3. Is it the first term, second term, third term? We can use this formula to determine that. Okay, instead of n choose r, NCR, I'm going to use this notation, which means the same thing. N choose r. Okay, same as NCR. And you use the formula in the same way. So the general term is n choose r, a to the power of n minus r, b to the power of r. Right? So we want the x to the power of 3 term. And n equals 7. We don't know the r yet. We're going to solve for r. The a is just x in this case, so it's going to be x to the power of 7 minus r. The b is 1 over x to the power of r. That's going to be equal to some coefficient times x cubed. Maybe I'll call it a or something. But so first of all, we want to figure out what the r value is. Now notice we can calculate it just by using the x's here and ignoring the coefficients. Okay, so here we have x to the power 7 minus r. This is x to the power negative 1. So this is x to the power of negative r. And that should be equal to x to the power of 3. In other words, these exponents should be equal on the left-hand side and the right-hand side. So we have 7 minus 2r equals 3. Then we have negative 2r equals negative 4. So r equals 2. Okay, so r equals 2. That will give us the x cubed term. So now just use the formula with r equals 2 and we can figure out what that coefficient is. So we have 7, choose 2, times the a value, which is just x to the power of 7 minus 2, and 1 over x to the power of 2. Okay, now there's a way to do this in your calculator. I'll show you in a bit, but you can do 7 factorial over 2 factorial times 7 minus 2 factorial. Alright, and then these x's actually, this should give me x to the power of 3. You can verify that. So to work this out, this is 7 factorial over 2 factorial times 5 factorial, x cubed. And 7 factorial, recall, is just 7 times 6 times 5, dot, 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 dot. And this 5 factorial is 5 times 4, and so on. So this 5 factorial cancels with this 5 factorial. We have 7 times 6 over 2, which is just 21. Okay, so that is the coefficient. That's the number in front of the x cubed, is 21. Okay, in the next example, we have x plus 1 times 1 over x plus x to the power of 4. And we're looking for the coefficient of the term containing x cubed. So if you think about it, this is x plus 1 times this. X times an x squared term is going to give you x cubed, and 1 times an x cubed term is going to give you an x cubed term. So we're going to have 2 x cubed terms possibly, and we can add those together. So what we need to do is we need to look for the x cubed term and the x squared term in just this one right here. Okay, so we're going to have, this is 4, choose r, and the a is 1 over x to the power of 4 minus r, and then we're going to have x to the power of r. That should be equal, let's do x cubed first. Again, just looking at the x's, this is x to the power of negative 1, so this is all x to the negative, x to the power of negative 4 plus r, times x to the r equals x to the 3. So negative 4 plus 2r equals 3. 2r equals -7. Okay, so looking at that, 2r equals -7. Actually, this is r equals -7/2. This, or +7/2. This is not a whole number, so actually there is no r cubed term in this one. Okay, so that makes it a bit easier for us. But we can do the same equation with 2 to find the x squared term. And that one works out. This is 2r equals 6, so r equals 3. Okay, so the coefficient's just going to be 4, choose 3, and you only get a 1 from these other two terms, so let's just work out 4, choose 3. You can use the formula in the formula booklet. It is this, which is just 4 factorial divided by 3 factorial. 3 factorials cancel, you have just 4. Okay, also, let me show you how to do it on the calculator. So on a TID4, you can go to Math, and it's over under Probability. And number 3 is N choose R. You'll need to put a 4 here, and 3 over here, and that's 4 choose 3, and it gives you 4. On the HP prime, so on the HP prime, you need to go to Toolbox right here. Let's escape here. Toolbox, and it is under, I think it's not under probability like the other one, it's under numbers. And, oh, maybe it is under probability. No. Oh yes, it is. Under combination, number 2. So press 2. We need 4 choose 3, so I think it's 4, comma, 3, and then enter, and it gives you a 4. Okay, so very useful for bigger combinations. Okay, and in our last example, we've got, in this case, we've got 1 plus x over 2 to the power of n, and they give you the coefficient of x to the power of 3. You got to find the value of n, so this is a little bit different. So let's use our general term again. So we have n choose r, actually, yeah, n choose r times 1 to the power of n minus r times half x to the power of r equals 70x cubed. So we can figure out what r is again by just looking at the exponents of x. So this is x to the power of r. This is a simple example. We have r equals 3. Right? So we have the r value. We'll go ahead and find the n value now by looking at the coefficients. So this is 70 over here, coefficients. So that means n choose r. This is just 1. Okay. And r we actually have is 3 right now. So n choose 3 times, this is half to the power of 3, should be equal to 70. So we ignore the x's, we just look at the numbers in front of x. So n choose 3 times half cubed should be equal to 70. So n choose 3, I'll use the formula in the formula booklet. N factorial over 3 factorial times n minus 3 factorial. Now this is 1 over 8, so I'm going to multiply both sides by 8. Okay, so now we have this equation, and I suppose we could type this into our calculator, but I'll show you what happens. We can do some canceling. N factorial is n times 1 less than n, times 2 less than n, times 3 less than n, and so forth. Right down to 1. 3 factorial, this is 6. And n minus 3 factorial is n minus 3 factorial, n minus 4, and so on. So this part cancels with this. And we just have n times n minus 1 times n minus 2 equals 3,360. This is cubic, so it's going to be a little bit hard to do by hand. We can solve on the calculator by graphing. So on the TID4, yeah, we can go to y equals and type in the function here. I've got it typed in x minus 1, x minus 2, and 3,360. Then you can go to Window. Now the end is probably going to be up to 30, so I went to X max 30. And I put the Y max up to 5,000 because it's a bit bigger than 3,360. Here's your graph. And the second calc, and find the intersection. And press enter, enter, enter. And we see the answer is 16. So n equals 16 is the answer. Okay, in part B, find the coefficient of x squared. So we just use a general term again. We have n is 16. R is going to be 2 for the x squared term. And then we've got 1 to the power of 16 minus 2. And we got half x to the power of 2. And then we can work this out, right? So on my calculator I can do 16 choose 2. Math, probability number 3. So I'll go back here, 16. Oops, I gotta do that again. 16 choose 2 is 120. So that's 120, and this here is half to the power of 2 is a quarter. So it's 122 divided by 4, which is 30.